Hello everyone, welcome back. Some people asked, can I have a small program? Can we see a small program? Before I get into it, I have observed that a lot of people are watching the entire training material. Very happy about it and thankful to you. If you really like this training material and if you are feeling that this is going to help you, give me a thumbs up. That will encourage me. Also, if you have any specific question on a particular slide, please put your questions. I will try to answer in the answer section in the YouTube itself. And of course, don't forget to subscribe because some more material is yet to be uploaded and you will get a opportunity to get a notification if you subscribe it. Now, this particular section, I'm not going into the program details, but one important is whenever you enter a program and exit assembler program, you see a lot of code in the beginning. It is, let us say, equivalent of your linkage section, something like that in COBOL, not exactly, but something like that. So I have taken a very small program and I also showed you the object module object code of that. The main purpose of this particular program is to tell you what is that we are doing at the entry of the program and at the exit of the program. Please go through, and as I said, if you have any questions, put it in comments, and if you like it, please give a thumbs up. Let's move on. I have taken few parts of the program, and if you really look at, there are three parts in this. The first part is where we are defining various registers. In fact, you can use the register numbers directly like I have done it here, or for easy understanding you can give them a name and you can use them in your program, which I will show you in my next slide. At this point, what is important is this is the actual program that is load into register 7 a full word 1. That's all. This is my entire program. As I said, my objective is not to talk about actual program but what is before and after. So we will talk about this, and we will also talk about the exit part of the program, which you will see in most of the assembler programs. In the previous slide, you have seen the entry part of the program, a small one-liner of the program itself, and then here we are seeing the exit part of the program. Here, as I said, I have used this save register, read register, and all that. That doesn't, it means basically the register numbers itself, which we have defined in the previous slide. For easy understanding, instead of saying 12 4 like that, we are using this. For example, base register is 12. And one more part we need to understand, there is something called a save area. Every program uses this save area, and it is a variable that is defined in the program itself. Don't think that it is like a register or anything. It is just a area, a space that is allocated. How much space allocated? It is 18 full words. That means 18 into 4, 72 bytes. And here I have initialized with a -1. You can initialize with any value, but it will be better if you initialize it with the -1, so that when you are doing debugging, etc., you will be able to understand where the data is populated and where the data is not populated. That is why I have put this with 18F with a initialization of -1. As I said, this is a 72 byte area that is defined. We will go into the actual start of the program and this exit part of the program in next few slides. If you look here, there are 5 commands, right? 5 instructions, and these are the same instructions which you will see in the start of the program. If you go back and see the program itself, you will see these 5 instructions. What is happening here? Before getting in, let us understand what is happening is you are moving from a program A to program B. Before the control is passed from program A to program B, you are saving the status of the program A in a place which is called save area, and then you are switching to program B. There you are trying to create a interconnectivity between program A and program B, and when the program B comes out, maybe you will save the status of program B in the save area. You may say, okay, in the program you have shown me, yeah, there's a one statement and there's nothing like a program A calling a program B. That is correct, but the control need not be between a COBOL program to assembler program or a assembler program to assembler program or anything like that. It could be control from anywhere to anywhere. For example, your JCL is calling your assembler program, and after your assembler program is completed, the control goes back to JES, basically the JCL operating system. It will go back there. Similarly, if you are calling a assembler program from a CICS, the transfer happening between the CICS and your assembler program. It is true for all the programs, right? So from CICS, it is coming to the assembler program, and once the assembler program is completed, the transfer is the control is going back to your CICS system itself. So it is important for the program where anytime this kind of a transfer is happening between one system to other, it is important to preserve the status of calling program before you move into the called program. So here you look at, there are two things. One is a register 13 and register 15. That is one part. Second part you need to know is it is a program A save area and program B save area. As I told you in the previous slide, we are defining a particular area called save area, and that is we are defining in each of the programs, or whether it is a just system or wherever there is a save area defined there. And let us assume here for easy thing that you are calling from program A to program B, and there are two registers involved here. Let us look at each of the statements what we are doing. When we have a program A has a save area which we defined, and as you can see it is a 72 bytes. What we are doing with this command stm, let's go word by word. Stm is store multiple. That means you are storing the value from the multiple registers, and from where you are doing it, from 14 to 12. Okay, so how do you read it? 14, 15, then 0, 1, 2, 3, registers go in a loop. So if you are looking at, you are starting from register 14, register 15, register 0 all the way to register 12. So what is missing here? Register 13 is missing. Why? Because we are using all this in the register 13 right now. So where is this program A save area is right now? It is there. It is in a, let us say, address called A000, and register 13 is pointing to this particular save area. So what we are doing here, we are taking the data of the registers from register 14, 15 up to 12, and we are putting in register 13, that is A00 plus 12. You know this convention, right? 12 comma 13 means in the register 13 plus 12. 12 is your displacement and 13 is the register. So in the register 13, the starting is A000. 12 comma 13 is A000 plus 12. That means A012. So what you are doing, you are taking the data of program A registers, and you are posting or you are saving that data in the save area starting from byte 12 onwards. Why not 048? We will see it in a minute. So this is what you understood, right? Please understand, save areas are two save areas, save area A and save area B. When it comes to registers, there are always only one set of registers. There is nothing like a registers for the first program and registers for the next program. Registers are same 16 registers. So that is why what we are doing, when we are about to exit from program A, we are taking the data of all the registers and we are storing in save area A, whose address is starting at A000, and we are starting from an offset 12 and we are storing it. Okay, I think you are clear about it. Store register R14, R13, R15 up to R0, R12 in program A save area starting at offset plus 12. Okay, Now let us come to this. Now I already switched to my new program. What I am doing is save area address I am storing in register 15. You see LA means load address. So my save area of program B assume starting at B000. So what I am doing, I am loading that address in register 15. That means what does the register 15 will contain right now? B000. What does my register 13 containing? A000. So my register 13 is containing the address of the save area of A. Register 15 is containing the save area address of program B, which is say B000. It could be anything. For our easy convention, we are doing it. So right now register 13 is pointing to save area of register A, and register 15 is pointing to save area of program B. Now what we are doing is we are we say cross pollinating. So what we are doing here is that you are taking 13. What is 13? That is the address of the program A save area, which is A00, and I am storing in my register 15 plus 4. Register 15, as I told you, is save area of B. Here plus 4, that is the offset 4. I am taking the address of it and I am putting here. But basically what I am saying is that I got called from this program. The address of the save area address of that program is A00, and I am taking and storing it in my current save area at a offset of 4. Clear this point? Store caller's save area address R13, caller save area address at R13 at offset plus 4 in program B's save area. So what I am doing, I am taking program A's save area, I am taking its address and I am storing it. Why I am doing it? We will come to that when we see the exit part of it. Now what I am doing, I am doing opposite of it. Now what I'm doing, I'm taking the address of my program B save area, which is where it is right now. It is in register 15. So I'm taking from register 15, which is B00, and where I am putting it, I'm putting in my register 13 offset 8, which is B000. What I'm doing fundamentally is that I am taking the save area address of the program A and storing in my current save area at +4, and I am taking the save area address of program B and putting in the save area of program A +8. Means my program B now contains where I called where I am called from, which is A00, and my program A save area is containing at offset 8 what I am going to call. So now program B save area knows address of program A save area, and program A save area knows address of the program B save area. If it is not clear, listen one more time, but I will also explain you a little different way. Now what we are doing, now I have done all this activity. Now I am switching my save area from 15 to 13. I told you, right, when we started, the register 13 is pointing to the save area of program A. Now I have done all this activity. Now I know that I stored my data of registers in save area A. Then I also kind of cross-pollinated the save area of A and B with each other's address. Now I am done with it. Now I can go back and reset my register 13 to show to program B. So right now register 15, what it is having, B00, which is the address of the program B save area, which I am loading in the register 13. Means now my register 13 is pointing to current save area, which is the program B save area. Why I am doing it? Because I will reuse the register 15. So uh, the first instruction is storing the program B's entry registers in program A's save area. So at the time of getting into here, whatever the data is in the registers, we are saving it here. The callers register contents are now saved in program A's save area, and program B can safely use the registers. Now why we are doing all this? Because as I said, there are only one set of registers. The moment you start using these registers in program B, you will lose the data in the registers. So before I do anything, I'm taking the register values, I'm putting in the program A save area, then I'm cross pollinating these two areas with this address there and that address here, and in the end I am pointing my register 13 to new save area, which is the program B save area. I know it is a little complex. Spend some time, go through each box, you will understand it, but I will also explain in a different way. Same concept, but it will blow up. I'm showing here one more time. Look at it. So program A save area is starting at A000, and right now register 13 is pointing to this save area. Program B save area is starting at B000, and register 15 is pointing to this save area. That's what we have seen when we said load address, right? And 15 comma save area, basically we pointed this. Then what we are doing is we are taking the program A save area address, which is A000, and we are copying that into program B save area at offset 4. That is what this particular statement is doing. So you are taking the A000 and you are putting at offset plus offset 4 in the program B save area. Then what we are doing, we are taking this B000 starting point and we are putting at offset plus, at offset 8. That means A000 plus 8. So program A save area knows that I am calling this program, which is this save area, and program B knows that I am called from program A whose save area starting at A000. So in a way, this is like a forward and backward compatibility. If you would have done any time C programming, you would have seen something called a linked list, and you would have seen something called doubly linked list. That means that every node is carrying the address of the forward node and the backward node. Here right now there is nothing is in the 8, but let us say program B is calling program C, then that program C's address will be coming here. So in a way this is like your linked list kind of a arrangement where every node knows that who is calling me and whom I am calling. That is what we are trying to achieve. First we are setting one link in using the R3 comma 4 comma 15. That means I am putting in my register the A program A save area here, and then in the next one I am taking this value and I am putting here. Once I am done with all these things, now I know backward and forward compatibility or backward and forward integration. I have done it. Now I am saying, okay, now register 13, you point to program B save area because I want to use the register 15. So let us say if a program B calls program C at that time, program B save area is pointed by register 13. No more register 15, and register 15 we will reuse it for different purposes. If you want, you can stop this video for a minute, watch it, go through each of these lines what we are talking here and see if it is making sense. All we are doing is first we are ensuring that each save area knows that where it is being called or where what it is calling, and once we set up this forward and backward integration, we are redirecting R13 to the latest program that is getting executed, and this continues if let us say program B calls C and program C calls program D. Keep the you can pause the video for a minute and go through all this content. Here we are looking at the exit routine. Basically, it is just opposite of what we have done during the entry. It is just a opposite of that. So if you have looked at, this is the program that is there, right? DS0H, where we are offered boundary, we are aligning, and rest of the area. Here you are seeing the save range and all that. If you remember, in the first slide I have shown that these are all nothing but different registers. Here also I have shown save register is 30, return register is 14, and base register is 12. For easy understanding, the same set of commands I have put in here. Here it is like more directly using the registers rather than these words. Now understand this, when we are just about to enter into this routine, the register 13 is showing the save area of program B. Program B save area register 13 is pointing to. That's what we did as the last command when we entered the program. Now register 13 is here, which is B00, and plus 4, that is at offset 4. What it is having? It is having the address of the program A save area, which is A00. That's what we thought here. So what this command is doing is, it is taking R13, that is this place, going to offset 4, which is this place, taking this value, which is A00, and we are putting into register 13. What it means is that now register 13 is pointing to program A save area. Remember, when we entered it, actually register 13 was showing the program A save area. After we have done some comments, we redirected program register 13 to program B save area. Now we are restoring back the register 13 to show the program A save area. That is the first part. Now this is my register 13. This is my register 13, which is program A save area. Now I am taking offset 12. What was there at offset 12? If you remember, register 14 address. What was the value in the register 14? That was there here, and register 14 is nothing but return address. So I am taking this return address and I am putting in my new register 14. Don't get confused, this is the save area and register is different. Before we moved into program B, we took all the registers and we put it in the program A save area. So plus 12 offset, at offset 12 register 14 address is there. What I am doing, I am putting back in my register 14. So what I have done, two things: register 13 I restored back, which is program A save area, and register 14 also I restored, which is program A's starting point, which is program's A's address. Now what I am doing, I am taking from 20 onwards the entire piece, and I'm copying back into register 0 to register 12. So what happened? Register 13 I restored, register 14 I restored, and register 0 and 12 from my save area I have taken, and I also restored them back into my program, into my register. So now I have picked up the data. Now I have picked up the data and put it back in my register. So before I move from program A to program B, how my registers used to look like, now they have come back to the same thing. Now I have to point my program to program A. For program, what is the address of the program A? It is in the register 14. So I am doing this. So what it means is that I restored my registers and I'm pointing back to my starting part of the program A. Please understand, uh, program A save area address is told in register 13, and program A starting point itself. Program A starting point is different from program A save areas address. These two are two different addresses, right? Program A save area is just a one variable in the entire program, whereas program A is where your C sect is there. That is a starting point. So now I'm asking the program, go back to the starting point of that. So if you look at R13 is initially program B save area, then I moved my R13 from program B save area to program A save area. This is just the opposite of what we did earlier. Then I restored back my register 14. Then I restored back all my registers all the way from 0 to 12. This is just a command to say that I'm giving control back to the system. And then I changed the pointer of my program itself to starting of the program, which is there in the register 14. Just one more thing before we wind up this particular class. Here you see this command stm 14 12 12 13. So if you remember in my entire class 2, I kept on telling this is how the object code looks like. So let me explain this here. stm is store multiple and it opcode is 90. Okay, so stm is 90. R14 14 is E, R12 is C, and R13 is D, and number 12 is 000C. So you see it here, 90 here, E here, C here, and D000C. Why? Because from the register D, I am at a displacement of 000C. That is why this STM 14, 12, 12, 13, you are seeing it as 90 EC D000C. Now let us go to LR 1215. This also I showed in our class 2. LR is opcode 18, R12 is C, R15 is F. So you are just seeing a 18CF. Here there is no address, or it's not referring to any address in the memory. It is just both are registers. You are just seeing a 18CF. Then look at this, we have done it. LA 15 save area. LA is here, this is this one. LA is nothing but 41. 15 is nothing but F. There is no second register here, so it is calling as 0, 41 C0, and save area is at a displacement of 04A. From where? From the base register. This is what I have explained there. Say 04A. Why you are staying using star comma 12, that means you are telling that my base register is 12. My program is, the starting point of my program is getting loaded at the register 12, which is C. That is why you say LA 41, 15 is F, and 0 because there is no second register unlike here, and save area is at a 04A. So you are seeing 41 F0 C0 4A. Now third one, we are looking at ST13 4 comma 15. That is this statement. ST is 50, 13 is D. There is no second register, so D0. And from 15, 15 is F. How much distance? 004. So let us say in our case, this is to be, let us say we talk about B000. So B000 plus 4. There will be B004. So ST50, 13 is D and a 0 because there is no second register, and you 15 you put it here F, and 0004. Same thing here, ST again 50, 15 is F and no second register, so it is again F0. Then 13 you brought it here D, and we did a 008. Since we have done this, I thought that it is a right point for us to showcase this. Hope you enjoyed this training, and let's move on.